Hello YouTube, this is Coolice here from Coolice Charge Cases and Power Supplies. I've got another new case to obviously show you all. Now obviously this case follows on from my previous iCharger 4010 builds, and indeed obviously houses an iCharger 4010 currently at the moment. But this case is featuring a variation on my PSU protection circuit. Basically, for those that have watched my other videos, with the iChargers there's a little bit of a fragile point to them, in that if you're using two power supplies in a pair to generate the 25 volts needed to obviously power them, if one PSU should fail abruptly, you can obviously cause damage to the charger. In this case there's a bit of a problem there, and they're not so well protected against the voltage and amp spike that sometimes ensues from the lone power supply that's remaining. So I'd obviously had a circuit made by a good friend to safeguard against that, and that dealt with the turning on and turning off of the power supplies, and allowed me to set a voltage window. So if one power supply should fail and the output voltage slipped outside of this programmed window, this controller would then switch off both power supplies, first shutting down power to the charger, stopping the charge cycle, and stopping any problems before they arisen with the charger obviously failing. Now, as we've gone along, we've obviously come across a need potentially for some other little features added on to that protection circuit. So we obviously needed to maintain the protection for the iChargers, but add some other things to it, and in this case some quite nice features as well to make it a little bit more attractive and more usable for everybody. Now, first of all, the first thing you're going to see obviously here is obviously we've got a case, we've got an iCharger in it, got the usual connections, 12 and 25 volt connection at the back, USB in the middle, and we can also see I've got my phone left there, which will come into play soon, and right down here at the front we've got our new display unit, which this is now the protection circuit, or a variation of the protection. We're still going to be having the other one, but this is an option for customers if they want something a little bit different and special. So we've got an LCD and a control knob. Now this control knob is a push and rotary one, so it's rotary to navigate through menus and obviously change settings, and push to accept, so it's clicky as well as turnable. Obviously I've created a little legend there with a clear display panel there, just to provide a little bit extra protection to the display screen. Eventually I'm looking to maybe have something else made here, but at the moment this is quite good with the vinyl protection there. It gives us some protection. So without going on too much further and not showing you what it does, I'm going to obviously try and keep the video on it, and at the same time flick the power switch, if I can go across there. There we go, and turn it on. Okay, now the unit is powering up, and it's obviously displaying my nickname. Oh, there we go. Now we're on and online. As you can see, we're displaying some information. So IceMeter by XY Gax, Steve Smith, guy behind it, who's done the design and the R&D work for me, and then obviously got the prototypes out, and together then we've isolated any little niggles that we had and just ironed them out ready for production. Now the first thing obviously display that's come up, it's saying V2. This is voltage 2, so this would be the 24 volt supply, which is currently at 0 because they're not turned on, so they're not giving any output. Now I can turn the wheel and show voltage 1, so obviously that would be the 12 volt supply, again not powered, so no voltage being shown there. The beauty about this protection circuit over the previous one is that we now have the ability to control up to 3 power supplies off this one. So essentially we can have control of over 3 power supplies. So if they're each giving 12.5 volts each, that's potentially a 37.5 volt power supply for your charger, which is handy. Some chargers obviously lap up the higher voltages, and the iCharger 4010 is one of them. So we could go, well, you could feed that charger with 50 volts, so obviously it becomes a little bit easier then. If we got 3 there, we could potentially give it 37.5 volts, which is a lot closer to 50. So that's the first screen. So we've got the voltage 1, I come back, voltage 2, temperature. This unit now has the ability to have a temperature probe mounted to it, which it has got, hence this one is actually displaying. And in the top right hand corner we've got obviously a little temperature icon. So that tells me the temperature probe is connected, it's obviously sending back a signal. Now what I've done, I've actually just left that loose in the case, and if anything it's just underneath the charger, because the output of this now, we can obviously set a temperature and at the certain point that I set it to, it will then turn on the case fans built into the back of the case. So when we're first using the charger, and obviously it's all nice and cool inside, the cooling fans to pull the air out through the case and out the back, they'll be off, but as soon as it gets to a settable temperature range, which can be programmed into this by the user, the fans will turn on and then go off when the temperature drops, and automatically then turn back on as the temperature rises again. I'll get my words out in a minute. Okay, I've just sat down, it makes it easier. Okay, so we'll scroll the wheel again. Overheat. We've got an option in this unit now to obviously specify an overheat temperature, at which point both power supplies would then be shut down, and this would be based obviously on that temperature sensor. So I've got it set on this case to 42 degrees C, so if the temperature within the case rose to 42 degrees C, or just above actually, again both power supplies would be shut down, the charge cycle would be stopped, and everything would just sit there nice. Scroll again, fans on. This is the bit that obviously ties into the temperature. So when the temperature inside the case reaches 28 degrees C, the fans will turn on. Nice and simple. Max current. There's capability for this unit to also deal with power supplies essentially up to 100 amps. There aren't many chargers out there that are going to pull that, but we've got the capability of pulling 100 amps through this unit and obviously monitoring it as well, so that's good. That's currently set to 92, so there's like an 8 amp buffer there before the 100, but that's fine. Minimum current. Right, now this setting here is, you'll notice obviously all my cases have the LED lights mounted within it, and previously the lights were controlled by an infrared remote. Now we've changed that for this controller here. We're now going to make the lights work for us. They're going to be there as instead of just being a visual thing, they're actually going to be there and actually telling us something about the state of our charging at the time. So what I've done here, I've set a minimum of 0.8 of an amps. Now what will happen is, when the ice controller or ice meter is detecting a current draw above 0.8 of an amps, the LED lights in the case will cycle, so they'll change colour, and they'll keep changing colour while the amps are being pulled at above 0.8. However, when the charger gets to the end of its charge cycle, and obviously the current draw reduces, in this case to 0.8 or lower, the lights will then change to green, which is what we're practically seeing now. So the lights then, instead of being a gimmicky feature, they're actually a status, if you like. They're a status indicator, so they're telling us when they're cycling and changing colours, the charger is obviously still working, it's charging our batteries. And then obviously if you look over your shoulder and see a green light coming out of your charge case, you can obviously assume your charging has finished. So another little feature, and it makes the lights, you know, more useful rather than just a gimmick. So let's come back again. Now we've got obviously to the parameters of the basic protection circuit. So of course this is over voltage protection, 28.5 volts. So if the voltage detected by this unit goes over 28.5 volts, both power supplies are also shut down. Now if I roll it again, one more, under voltage protection, this is the one that obviously protects the iChargers as well again. So if the voltage dips below 23.05, there's a 0.05 increment in there, then again both power supplies will be shut down, iCharger protected, and the charge cycle is stopped. Come back once more. Current, again, not pulling anything at the moment, so the current is 0, 0. so there's nothing being done. This will obviously be, as we're charging, this will obviously match up with whatever current the charger is wanting to pull from the power supplies at the time. So there's nothing on, the charger isn't powered at the moment, so there's 0 amps there. Once more, now we're back to the voltage one, so V1, 12 volt, first power supply, nothing. So in order to start the power supplies now, they're obviously powered but they're not on, we press the little knob. Now obviously you can see here we've got what would probably essentially be called an angel ring of light. We've got an LED obviously mounted under there, so that obviously changes colour and changes the colour of the knob. Nice little feature there added by Steve. So we'll press it. Voltage of power supply 1 has come up. You can obviously hear the charger booting up in the background, and sure enough we've got voltage now on the charger. No amps. Come back here to the display and we've got 12.4 volts coming out of one unit, and then the two combined 24.85. and the calibration on this is very good. I think Steve told me it's within 3% I think from this, and also the current draw as well, so he's done really well. So anyway, we're now running, charger's running, we can obviously see what's going on. So V1, V2, yeah, nothing there. Temperature is slowly going up, not very quickly, it's just obviously slow because we're not pulling anything, nothing's generating any heat yet. Okay, that's all the same, we've just been through this. Obviously it's difficult to see perhaps because the light's not great, but I'm just scrolling through it. There we go. Okay, now it's difficult for me because obviously I haven't put a balance lead in, but if I grab my load from somewhere, I'm going to pause this for a minute. Okay, I'm back. What I've done, I've got quite a basic load, if you like, which I can show you over there. Everyone jokes with me about this. This is my converted hairdryer. This basically gives me a 1 ohm load. So with the iChargers, I can regenerative discharge from one channel to the other. So instead of having to discharge into and wasting heat in the charger, I can discharge my packs into this load, which is ideal at the 1 ohm, which has been deemed to be good for the iChargers. And of course, it's a hairdryer, so it's got a fan in the back. It's got the heating coils in there, which obviously dissipate the heat, and the fan keeps them cool. So it's perfect. So it's going to be a little bit noisy, but for the purposes of this display, this should hopefully work just right. Let me just make sure everything's okay. Yeah, okay, now I've got my load set. Obviously the power supplies are off at the moment, so what I'm going to do is I'm going to turn them on. Yeah, and you can obviously hear my hairdryer is now working. Obviously for the purposes of this video I've just got them plugged into the 12 volt. This load would also work on 25 volts, but it would be even louder, which I don't want at this moment because I'm obviously trying to show you everything. So as you can see, the load is running, it's pulling amps, and the lights within the case, you can see, are now changing colour. So that demonstrates that that side is working. Obviously you can see them, they're going. Let's go back to the display. I think if I scroll to the right, current, there we go. So that load is currently pulling 8.25 amps through the 12 volt terminals at the back. And because of that, the lights are changing colour within the case. There we go. So they're going purple, pink, red, purple. They're cycling. So we're mimicking a charge. Now what I'll do, just to prove the theory, if I disconnect the lead, that obviously disconnects the load, the lights should change green. And there they go. The lights change green, the load's disappeared, so we're assuming the charge cycle is complete, and the lights are also going to show. We can plug that back in. Yeah, sorry, made me jump where it fell down. And there we go, the lights are cycling again. We're back up to 8.25 amps. Brilliant. So now, without too much, I'm going to leave that running there. Shouldn't get too warm. Everyone laughs about my Revlon load bank at the back, but anyway, it's quite funny. Now, the eagle-eyed among you may obviously have seen the little Bluetooth symbol flashing away there. That's because this little unit has Bluetooth. What's it for, I hear you ask? Well, I'm going to show you. At the moment I'm using an app, basically just downloadable for free from the from the Android Market Store, but in the background both myself and Steve, we are trying to get our head around Android coding and come up with a dedicated app that will obviously show you or give you the information that I'm going to show you is available in a minute. So I'm going to get my phone now. Again, follows usual convention. You obviously pair the Bluetooth module to your phone, which I've already done in the background, and I've got Bluetooth obviously turned on. You can see my page there. So I'm going to go apps. Top right hand corner I'm using the Apple, or not the Apple, Bluetooth SPP Pro, which is a free app. Come across this way, might help. Okay, now that's searching for a Bluetooth device. Now it's already got mine, which is there, so I'm going to click it, saves it. We're going to connect to that one. Click connect. Okay, now this option gives us a couple here, but the one we're interested in at the moment is keyboard mode, so I'm going to click that. Now what I've done here, let's come on this side a little bit. What I've done is you can program with this unit buttons, so as you can see, PSU 1 volts, PSU 2 volts, PSU 3, low cutoff current, everything that's on there. Basically I've assigned the relevant hex code to those buttons, so when I press them it's going to send hex code out, which the display unit is also going to receive via its Bluetooth module, and then it is then going to send information back to my mobile phone. So at the moment, if I go to V1, which is power supply 1, we've got 12.4 volts there. So if I come across to this, show you the screen and press PSU 1, as you can see we're showing 12.4 volts. I can press it again while we're there and we're getting live information of 12.4. Come across, scroll to V2, which is the two combined, 24 volts, 24.75, 24.8, according to that. Press the PS2 2 volts button and we've got 24.75. That's the voltage coming out of it at that present time. 24.8, there you go. If I press PSU 3, there is no PSU 3, so it's going to return a 0 volts. So at the same time we can obviously check various other settings that have been set. So we've got low cutoff volts, and obviously previously on the video that showed the 23.05 of a volt. We can obviously check the current amps being pulled by clicking the current button, 8.25. If I scroll back, oop, missed it, 8.25, 8.25, and also I can click it again and double check it, 8.25. Upper voltage cutoff, click that, it interrogates it and tells it, oh, it's gone on the wrong page. There we go, 28.5 volts, so that's the point at which it will cut off. Current temperature, 24.7 degrees C, we can check that, 24.8 degrees C. Current temp, where are you? 24.8, perfect. Fan on temp. These are just buttons basically I've set at the moment just to test everything. Basically this is the kind of app we're looking to replicate, but basically with a line of information down this side, so PSU 1, PSU 2, PSU 3, and then text boxes on the side showing all this information without having the need to press buttons, and it'll auto refresh every couple of seconds or whatever. But that's obviously taking a little bit longer for us because neither of us know Android, so we're having to learn it, which is all good fun. Now, some of you may also have seen here, if I go back to the voltage, you can leave it on whichever one, it doesn't matter. You can see obviously the name, so currently IceMeter by XY Gax. Now the IceMeter will stay, that'll always be there, but we can rename that unit to, we've got a possible 8 characters there, and the production units that these have now you can actually rename it and write it to the EEROM, so it will remain there until you change it. Obviously I've not got those codes set to my buttons, but I can temporarily change the name until obviously we switch it off and obviously lose settings. So I've got this button here set to change the name to Coolice, so if I press it, there we go, it's now changed the name. I've got set Kim, that's my wife's name, so if I press that, Kim, and I filled up the other extra characters with some other little characters just to prove it. Now I'll move the phone away because there'll probably be a little question that it's not wireless, but it is. So if I turn away, I'll face my computer a little bit and obviously press the PSU 1 volt. We got 12.35 coming out of 1. Press it again so it goes on one line. 24.8 volts coming out of 2. Press it again. Current 8.25 amps. That's obviously staying constant because the load isn't changing, it's constant. And current temp 25.3 degrees C. I can obviously change the name from here, so we'll go back to the display. It's currently got my wife's name on it. We'll press Coolice, press it twice accidentally, and it's gone back to Coolice. Also, while I'm here, before we walk away again, I can shut it down. So if I press the reset button, it's then switched it off and it's rebooting, and we're back on ready, but obviously it's not running. So that's it, really. That was obviously what I wanted to show you all. Obviously I've been quite excited about this. I've had a pre-production sample one for a couple of weeks now. This is the first case build with it, so of course it was quite nice to obviously build it, create everything and get it all set up, which is nice. I hope you've enjoyed this video again. Please leave your comments, I appreciate it. See you soon, bye bye.